Hello my children, this is P. Venkateshwarlu, PhD Physics, the Nandal Public School. In previous video, we discussed about electrostatic potential energy for different types of charges for system of charges. Yes, in this video, we will discuss about potential energy of a dipole. Potential energy of a dipole in an external electric field. Okay, see here we have to find electrostatic potential energy of a dipole. So first of all, what is dipole? Okay, dipole is a system of two equal magnitude charges separated by a small distance. Clear? See, here consider two charges, Q minus Q. Okay, both equal magnitude and opposite in nature, which are separated by a small distance. That distance we are denoted to L. Okay, this we can say electric dipole. Clear? Yes. Next, what is electric dipole moment? Electric dipole moment. Okay, dipole moment is denoted P bar, which is defined as the product of magnitude of charge and separating distance. Okay, P bar is equal to Q into 2L. It is called electric dipole moment. In previous case, means in electric charges and field chapter, so we calculate the torque which is acting on the dipole which is in uniform external electric field. Okay, so we need that equation. Yes, clear? So torque acting on dipole. Okay, see here, this small content also completed, very important one. Okay, see here, it is uniform electric field. It is uniform electric field in which we have to take one electric dipole. Okay, clear? Electric dipole, here plus charge is there, here minus charge is there. Clear? So due to separation distance 2L, okay, when this type of dipole placed in a uniform electric field, F QE is applied on the charge. Okay, here minus F is equal to QE or F is equal to minus Q. So due to this, what happened, which is aligned with some angle which rotates horizontally. Here 90 degrees, here some angle. Okay, so in this case, what happened? The dipole rotates. So whenever this type of dipole placed in a uniform electric field, torque is acting, which tends to rotate the dipole. Okay, here torque is we need to find. Okay, because 2L, the component of 2L, which is along 2L cos theta, along vertical 2L sin theta, we have to get. Okay, it's clear. This is based on the component. So we know that torque, which is equal to force into perpendicular distance. Okay, what is force here? Which force acting? F is equal to QE. So what is the perpendicular distance? Yes, 2L sin theta. Clear? So tau is equal to Q into 2L E sin theta. Clear? My children, clear? Yes. So then tau is equal to Q into 2L, P bar, P and E sin theta. Okay. So according to vector product, we have to write tau bar is equal to P bar cross E bar. Clear? So this is the previous derivation. So which is very very important. Okay, from this we need to find potential energy of a dipole in an external electric field. Clear, my children? This entire this derivation is previous chapter. Okay, clear? So we need to take this equation. Okay, what is the torque, my children? What is the torque? Torque is equal to P sin theta, or tau is equal to P bar plus E bar. Okay, clear? Yes. My children, okay, see here we have to find how potential energy we have to calculate. Okay, see how potential energy is calculated. See here how we can find the potential energy in this case. While dipole rotating in an electric field, some amount of work is done. Okay, so some amount of work is done to rotate dipole in uniform electric field. Okay, it's clear that amount of work done dw is equal to F into dx. Okay. So this is normal form. In the case of this dipole, dw is equal to tau d theta. Okay, because the dipole which rotates some angle, we can say some work is done. This work done which stored in the form of electrical energy, electric energy or electric potential energy. Clear? Yes. So U is equal to dw is equal to tau into d theta. How we can get the total work done? By integrating. So by integrating 0 to w, here by integrating theta 1 to theta 2. Okay, clear? U is equal to w minus 0. Then integration of theta 1 to theta 2. What is tau? P sin theta d theta. Clear? Right. So W is equal to U is equal to PE. It is common. Integration of theta 1 to theta 2 sin theta d theta. Okay. So in the case of integration of sin theta d theta, so we have to get minus cos theta. PE minus cos theta, lower limit theta 1, upper limit theta 2, because integration of sin theta d theta is equal to minus cos theta. Okay, clear? So now we are applying limits. Okay, minus, we have to take out minus PE cos theta 2 minus cos theta 1. Okay, clear, my children? Yes. Finally, we have to get PE cos theta 2 minus cos theta 1. Otherwise, rearrange this PE cos theta 1 minus cos theta 2. This is the final expression. My children. Clear? So this is the potential energy of a dipole in an external electric field. Okay, U is equal to PE cos theta 1 minus cos theta 2. In this case, you can have some special cases. Okay, see, my children, very important one. Okay, right. So special cases. Very important one, this equation. Electrostatic potential energy, final expression, U is equal to PE cos theta 1 minus cos theta 2. See here, suppose case 1, theta 1 is equal to 0, theta 2 is equal to theta. So if theta 1 is equal to 0, what happens? U is equal to PE cos theta 1 cos 0, how much, my children? cos 0 1, cos theta 2 cos theta. Okay, so PE 1 minus cos theta, PE 1 minus cos theta. Clear? Next, this we have to write u is equal to minus, we can take out PE cos theta 1 minus 1. In the case of case 2, so how to take theta 1 is 90 degrees to theta 2 is equal to theta. Okay, so we have to substitute in this equation. So how to get potential energy PE cos 90 degrees minus cos theta, cos 90 0, cos 90 0 minus 0. Okay, clear? U is equal to PE cos 90 0 minus cos theta minus PE cos theta. Okay, see here PE cos theta, AB cos theta. In the case of AB cos theta, we have to write A bar dot B bar. Okay, so this we have to write minus P bar dot E bar. Okay, clear? This is also very important one, my dear children. Important keywords based on the electric potential energy. So first one, electric potential energy at any point on the bisector of dipole 0. See here, suppose in a dipole is there, yes, this is plus q, here this is minus q, here this is bisector, here the value is 0. So at that point electric potential energy at any point on the bisector of a dipole is 0. And second one we have to discuss, a dipole experiences a net force in a non-uniform electric field. And third one, a dipole experiences maximum torque at the position where the potential energy is 0. It's clear, my dear children? Yes. Potential energy of an electric dipole in an external field. Consider an electric dipole of dipole moment P is placed in a uniform electric field E. The dipole experiences two equal and opposite forces plus QE and minus QE at ends forming couple. Couple means torque. Magnitude of the torque on the dipole is tau, magnitude of the force arms of the couple, perpendicular distance, QE into 2L sin theta. Then we have to write PE sin theta because Q into 2L is called P. Work done in rotating the dipole through small angle d theta, right? dW is equal to tau into d theta. The total work done in rotating the dipole from initial orientation theta naught to the final orientation theta is W is equal to minus PE cos theta minus PE cos theta naught. If the initial orientation is theta naught is 90 degrees, then work done is equal to minus PE cos theta. According to dot product, we have to write this work done stored as potential energy. Thus, potential energy of the dipole is U is equal to minus PE cos theta. Coming to previous NEET questions, an electric dipole of dipole moment P is aligned parallel to a uniform electric field E. The energy required to rotate the dipole by 90 degrees is. Next question, an electric dipole of moment P is lying along a uniform electric field E. The work done in rotating the dipole by 90 degrees is. Both questions are similar, my dear children. Right. What are the given in the screen? Okay, so these two problems one to another which are similar, which are asked in previous NEET. In this case they given two angles. that theta 1 is equal to 0, theta 2 is equal to 90 degrees. In both cases, they asked, in two cases, they asked this question and they given this data. Theta 1 is equal to 0, theta 2 is equal to 90 degrees. So what is the potential energy of the dipole? Okay, so we know that how we can get the potential energy. So we know that tau is equal to P bar cross E bar. We know that P sin theta. Okay, so then how we can get the potential energy? Potential energy or work done is equal to PA cos theta 1 minus cos theta 2 in previous derivation. See, in this case we have to substitute the values. PE is same, cos theta 1 0, cos 0, then cos theta 2 cos 90 degrees, cos 90 degrees. PE cos theta 0, cos 0 1 minus cos 90 0 degrees. So PE potential energy is maximum. My children, in this case potential energy is maximum. It's clear, my children? Yes. Next, an electric dipole of moment P is placed in an electric field of intensity E. The dipole acquires a position such that the axis of the dipole makes an angle theta with the direction of the field, assuming that the potential energy of the dipole to be 0. Theta is equal to 90 degrees. The torque and the potential energy of the dipole will be respectively. To next question, my children. Next question. So coming to next question, in this question is very simple question, theoretical question. So what is the potential energy? What is the potential energy? So we know that torque is equal to PV sin theta and potential energy which is equal to minus PV cos theta. So the amount of work done we have to write P bar dot E bar, P bar dot E bar. Clear? Clear, my children? So how we can get, my children, this one? Yes. So we know that minus PA cos theta 2 minus cos theta 1. So in this case, so we have to take the angles which are cos theta 2. Theta 2 it becomes 0 degrees and 0 degrees. Theta 1 it becomes 90 degrees. Then only we have to get minus PE cos theta 2, cos theta 2, 0, cos 0, cos 0, 1, cos 90 degrees 0, okay, minus PE cos theta means minus PE. Suppose in this case we have to take theta to theta, we have to get cos theta minus PE cos theta. Okay. Clear, my children? This topic is very important for board exams and NEET exams.